Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.
About graphings or functions. We've done functions too, but I think I might revisit them later. So let's start from the very first page 1 of 20. All right, so for instance, you have this. I think I need to zoom in a bit. You can see it. Please try and zoom in so you can see it from your end. This first question says, on the graph, on the grid, draw the graph of y equal to 4 over x for 0.5 less than or equal to x less than or equal to 10. Basically, it's asking you to find tables of values of x and y from 0.5 to 10. So you just just substitution. For instance, when x is 0.5. When x is 0.5, you know what you do? You simply do 4 over 0.5, isn't it? And then that gives you 8. That's how we got all these. Got all these values. For instance, when x is 10, you simply do y will be equal to 4 over 10. And that's how we got 0.4. Alright, so all these values of x and y is what we have here, and we plotted them to get this. To get this graph. Yes, we did the same thing for this other one. I just want to mention some important points to you. Now, a graph like this usually forms what we call asymptote. A graph of y, for instance, y equal to 2 over x or y equal to 4 over x, it forms what we call an asymptote because it will be trying to touch an axis, but it will never touch it. Let me tell you why it will never touch that axis. Are you ready?
Yeah.
This graph will never touch the y-axis, and let's see first of all why it will never touch the y-axis. Why it will never touch the y-axis. Why will it not touch the y-axis? I need to help you to reason out something. What is this coordinate? Please zoom in. Let me zoom out or zoom in.
0.4.
Okay, this particular coordinate is 0.4, right? You know, you name the x value before the y value. That's correct. 0.4. That's this coordinate here. Think about this equation. You said this coordinate is 0.4, isn't it? Now look at the equation. Y equal to 2 over x. 2 over x. 2 over x. So, what's the value of x on this coordinate? This particular coordinate, let me call it P. What's the value of x there?
0.
0, okay. In other words, when x is 0, what would this be? You know, you substitute. When x is 0, what will y be? You may need to scroll up. No. Check. Put it in the equation. When x is 0, what will y be?
0.
Yeah, just don't assume. Use your calculator. That's why I asked you to get your calculator. Find what y will be when x is 0.
Just math
it said max error, right?
Yeah.
Which means it is undefined. It is infinity. You know, you can't, there's no value like that. It is infinitely high that there's no way to record it. In fact, anything over 0 is infinity.
Okay.
What is the implication? The implication is x can never be 0. For this function, x can never be 0. X can never be 0. Since x can never be 0, it will never touch the y-axis. This graph will never touch the y-axis. It will be coming close to it, but it will never touch it. Because once it touches it is when x is 0, isn't it? Because at the intercept, if it ever touches it, that place will be where x is 0, which is intercept. And since for that to happen, it should have a value of y. I'm saying 2 over 0 should have a value, but it doesn't have a value. Even your calculator says no value, it's a mass error. It's infinity, it's undefined. And since it is undefined, it can never touch the y-axis. It can't touch it. It will be coming close to it, but it will never touch it. We call that asymptote.
Okay.
So the graph approaches a given value of y or x, but will never get to or touch it. That's what asymptotes mean. You find asymptotes in situations like this, when it is going to be infinity, like y equal to 2 over 0. 2 over 0 is infinity. So when x is 0, it will be infinity. So it will never touch the y-axis. All right. Those kind of graphs form asymptotes. You know, sometimes you may find them in 2 different separate parts of the graph. Okay. So let's go to the next page. I want us to look at different types of graphs. We have linear graphs. You know, a linear graph, as the name implies, forms a straight line. What's the equation of a straight line?
Y is mx plus
Y exactly, y equal to mx plus c, where m stands for what?
gradient.
Gradient, yes, m represents the gradient. In this case, the gradient is positive. The gradient is positive because it's sloping upwards. An example is y equal to 3x plus 2. I can zoom this thing in a bit. An example is y equal to 3x plus 2. What's the gradient? What's the value of the gradient in y equal to 3x plus 2?
Sorry, what did you say?
What's the value of the gradient in this equation, y equal to 3x plus 2?
3.
3, because that's what is taking the place of m. So the gradient is 3, and it is positive. It's a plus 3. That's why it's going to slope upwards. What's the intercept?
2.
2 is the intercept. That's why, you know, the intercept is where it cuts the y-axis. So this value is 2. So what do you think is the coordinate of this intercept? I'm circling.
What's it called? 0, 2.
0, 2, excellent. You see, remember all this. That's really beautiful. So the coordinate of this intercept is 0, 2, where 2 represents the value on y and 0 represents its value on x. All right. Now, linear graphs, it could form a positive slope, in other words, it slopes upwards, or a negative slope where it slopes downward. An example is y equal to minus 2x plus 5. What's the intercept here?
5.
5. That's why this thing crosses here, where it is 0, 5. So the coordinate of this point is 0, 5. All right, that's for linear graphs. You can have linear graph with a positive slope, linear graph with a negative slope. Then let's look at quadratic graphs. Quadratic graphs will form a curve, you know. It could be a U or an N. The general equation of a quadratic function is ax squared plus bx plus c, y equal to ax squared plus bx plus c. You know that. So if a is positive, in other words, it is greater than 0, if a is positive, it will form a u.
Okay.
But if a is negative, it will form an n. What's the value of a in this one I'm circling?
2.
2. So it forms a u. Because it's positive, it forms a u. Now these positions are where you have the roots or the solutions of the equation. These x values are the roots or the solutions of the equation. We get there. Now if a is negative, like y equal to minus 2x squared minus x plus 6, it will form an n. This one also has intercept. What is this intercept? What is the coordinate? What is this coordinate? Let me even ask you.
-2.
Give me this coordinate.
0
0
-2.
minus 2. You can even see it here. This is a C. Did you see what I'm circling?
Yeah.
Okay, what's the coordinate? What's this coordinate here? But let me write this one you just mentioned. You say here is 0 minus 2. What about this one? What's this coordinate? 0, 6. You can see that from the equation itself. Now remember, it forms an n because a is minus 2, a is negative, so it forms an n. And the intercept is plus 6, that's why you have it here. You can sketch it. These x values are the roots. Now, what you will get if you solve this equation, either by general quadratic formula or factorization, if it is factorizable. It looks like this is factorizable. Let me see. 2 times 2 is minus 3, minus 1. This is factorizable. Can you quickly solve this by factorization? Can we squeeze it in here? See the space I created for it on the right hand side, on the left hand side. Let me write the equation. 2x squared plus 3x minus 2 equals 0. I think it's factorizable, so let's solve it by factorization. 2x squared plus 3x minus 0. Okay. 2x squared plus 3x minus 2 equals 0. You may need to really zoom in, maybe to 200% to see it properly. Okay. I don't know if you can see where I put it in.
Yeah, I can.
Are you solving?
Yeah.
All right.
Okay.
All right. You remember, you multiply the coefficient of x squared by this first of all. Looks like your pen is glitching.
Yeah, I'm pretty sure that's just mine.
Please tell me what to do so that it doesn't delay. Tell me what to do.
Yeah, so 2 times minus 3
So we start by saying
One.
coefficient of x squared multiplied by c. So 2 times minus 2. That gives us minus 4.
One.
So you find the factors of that such that 2 of them add, sum of it will be plus 3. Product of it will be minus 4. So what are the factors? By the way, the factors of 4 are
3 and 1.
1,
Oh,
2, 3, 1, 2, and 4 itself.
So 4 and 1.
4 and 1. Okay, so what will be their signs?
Hold on.
1 times the other will give you plus 3. Sorry, 1 plus the other will give you plus 3. 1 times the other will give you minus 4.
4 and minus 1.
4 and minus 1, okay. 1 times the other will give you minus 4. 1 plus the other will give you plus 3. Okay, it's 4 and minus 1. So the conditions are plus 4 and minus 1.
Yeah, and then
So we use that.
yeah, and then
So we're going to do, we are substituting these two, we're using them to replace plus 3x, isn't it? So that's going to give us 2x squared. Instead of plus 3x, we're now writing these 2 to replace it. So we have, let me still write it the way it is, plus 4x minus 1x if you like, or just x, then before minus 2, and equals 0. Then you factorize pair by pair, isn't it?
yeah,
The first pair and the second pair. So the first pair will be this first pair. We factorize also we factorize the second pair. 2 can come out. 2 comes out. We have x squared plus 2x, or even 2x can come out. Let's bring out 2x. 2x can come out. We have x plus 2. That's for the first pair, which is this. Now for the second pair, what can come out? Please look at it. This second pair, what can we bring out?
minus 1.
Minus 1, good. We bring out minus 1. Let me use a red pen. I think a blue pen is better. Minus 1 comes out. So what would we write?
1.
No, minus 1 has come out.
Yeah, no, so x
X
plus 2.
plus 2. You will notice that this sign is going to change because a minus is opening the bracket. It always changes the sign. Or a minus is closing the bracket, so it's going to change this sign to plus. Okay, so once we have this and this together, it's going to give us, we pick,
2x minus 1 and x plus 2.
alright, so we pick each one of those in brackets, x plus 2 and then 2x minus 1. We did this in the previous lesson anyway. So pick any of these two, which are similar, and then pick the ones outside, 2x, and then minus 1. Okay, so with this, we can just factorize. X plus 2 equal to 0 will give us what?
Minus 2.
X plus 2 equal to 0 means x is equal to minus 2. Then the other one, x plus 2x minus 1 equal to 0.
X equals
2x minus 1 equal to 0 will give us x equals what? Solving that equation will be 1 over 2, right?
yeah, which is all
Or 0.5,
0.5, yeah.
you know. So those are the x values. X values are minus 2 and 0.5. I'm just trying to tell you that these positions, this and this are, what are these values, x1 and x2?
What do you mean?
These values, x1 and x2, what are they? Remember, this is the question we solved though. This what I'm circling.
Yeah.
Look at it. Make sure you're on your Jamboard, please.
Yeah, I am.
We solved this to find these two values of x minus 2 and 0.5. So what are these values, x1 and x2? All these things we found now are the solutions. Those are the values.
Okay.
So what's this one?
X minus 2.
This is minus 2, good. You know, if you were to sketch this is what you would do, isn't it?
Yeah.
Why this one is what? This other x2 is what?
0.5.
0.5. You know, it's not drawn to scales, but if you were to sketch this is what you would do. And then the final thing would have been to find the coordinate of the turning point. We've done that in another lesson. You know, to sketch the graph of a quadratic function, just to remind you, you need to find the roots where the graph cuts the x-axis. The roots are also called the solutions. x1 and x2 are the roots or solutions where the graph cuts the x-axis. And then you need to know the intercept. We know the intercept is this value, 0 minus 2, which is here. And then you need to know the turning point. The turning point, you get that by completing of square. We've done that in another lesson.
Okay.
Are you on the next page?
Yeah.
All right. So other types of graphs, we have exponential graphs. Exponential graphs, you know, you have some of them will slope upwards, some will slope downwards. The one sloping upward is, of course, the ones sloping downwards are decays. This is like a rise. This is the decay. Anyways, if you're going further in your studies, you will meet stuff like that. Basically, exponential graphs have a constant raised to power, a variable, like a raised to power x.
Yeah.
A constant raised to power variable. An example is y equal to 2 raised to power x. If this x is positive, it will slope upwards, which is a rise. If the x is negative, it will slope downward, which is a decay, an exponential decay. Let me ask you a question. What will be the value of y when x is 0?
What would be the value of C?
Are you sure? When x is 0?
When it's 0, is the A not just 1?
Y will be equal to what?
I'm saying when the power is 1.
Yeah, when x, yes, whenever a power is 0, anything raised to power 0 is 1, yes. But remember the graph itself is y equal to ax plus c. Ax plus c.
So 1C, so C.
Or you mean 1 plus c.
1 plus C, sorry. Yeah.
So when x is 0, because a raised to power x is 1, if x is 0, then y will be, the whole of this place will be 1 plus c. So y will be 1 plus c. That will be the intercept. You know, the intercept is when x is 0, isn't it? So what the coordinate of this point will be 0, comma c plus 1.
Okay.
Is it not?
Yeah.
The same thing we apply here. What will be the value of y when x is 0?
Well, because it's a minus.
It's the same thing because a raised to the power 0 or minus, there's nothing like minus 0 or plus 0. 0 is 0. So a raised to the power 0 is still 1. Then 1 plus c will give you 1 plus c or c plus 1. So the coordinate of this place will be 0, c plus 1.
Okay.
Okay, let me just indicate that this coordinate. Oh, sorry. How do I indicate it? This coordinate is 0, then c plus 1. Is it? I think I might have to zoom in to write it properly. Let me zoom in. This coordinate, I think I will use a yellow pen. 0, c plus 1. Also, this coordinate is 0, c plus 1. You know, that's the intercept. All right. Don't forget that if x is positive, its slope is upward, which is an increase or a rise. If x is negative, it's going to slope downward, which is a decay. Now, the last one we look at will be polynomial graphs. Are you listening? For polynomial graphs, the highest power of x will be 3 upward. For instance, ax cubed plus bx squared plus cx plus d. Y equal to ax cubed, that's ax raised to the power 3 plus bx raised to the power 2 plus cx plus d. Is a polynomial graph because it has a power from 3 upward. The highest power is from 3 upwards. The highest power will determine how many places it will cut the x-axis. If the highest power is 3, it will cut the x-axis in 3 places. So you can have 3 different values of x for 1 value of y. Like here, here, and here. This will be the positions it will cut the x-axis. So this will be the solutions. Or this, and this. Okay, I think we need to go back to the question I gave you. Let me see what you will do here. Shall we?
Yeah.
So match, the question says, match each graph to correct equation. Match each graph with the correct equation.
Okay, yeah. So, yeah, okay, done it.
Are you sure? Can you cross-check?
Well, I know B is right for sure.
Okay, you know B is correct, so I'll mark B for you.
I think I just need to swap D and C.
I can mark A for you too, because A is quadratic. You see,
Yeah.
y equal to x raised to the power 3 is actually D.
Yeah, I said I was gonna swap it and then I just wrote the same thing.
Oh, okay.
So, yeah.
Because it cuts the graph in 3 places, as you can see.
Oh, yeah, okay.
And y equal to 1 over x is obviously c. Those ones that will form asymptotes. Can you see it's forming asymptotes? Are you listening to me? It's trying to touch the graph, but it can't touch, so it's forming asymptotes.
Yeah.
Go to page 4 of 20.
Okay.
We've done this. I just want to review it with you so that you see what we've done before. Read out the question, please.
The table shows some values for the function y equals 11x minus 2.
I'm sorry. Let's do this first of all. Let's do this one. This one on the left-hand side. This is the graph, and these are the questions. Can you read it out? You may need to zoom in to see it properly. And of course, it's going to form an asymptote because once you start having something over, okay, maybe you may not, but let's see. Can you read out the question? Let's go.
The diagram shows the graph of y equals x over 2 plus 2x for 0 less than x more than less than or equal to 8. Use the graph to solve the equation.
X over 2 plus 2 over x equals 3. So the diagram shows the graph of y equal to x over 2 plus 2 over x for 0 less than or equal to x less than or equal to 8. Use the graph to solve the equation x over 2 plus 2 over x equals 3. So what do we do?
Okay, so right, then we just what's the graph solve the equation?
I'm listening.
Yeah, then we just do like make a table and then.
Are you sure there's no need for a table? The graph has already been plotted.
Oh, okay.
You make a table when you need to plot the graph. The graph has already been plotted, so we don't need a table of values. Okay, I'm listening.
I don't know.
Okay, it says, look, anytime you're given this kind of thing, look at the original equation plotted. Original function. What's the original function?
Y equals x over 2 plus 2 over x.
Yes, the original function is y equal to x over 2 plus 2 over x. And you are asked to find the same thing, x over 2 plus 2 over x, but this time around equals to 3. Now, doesn't that show you that it's basically saying what is replacing, what has changed? If you notice, what has changed?
Y equals 3.
So it simply means y is equal to 3. Because this whole place is still here. Now y is being replaced by 3. So what does that simply tell you? Draw the line of y equal to 3.
Hello?
Yes, I said what that simply tells you is to draw the line of y equal to 3. Because y is equal to 3. So you simply draw the line of y equal to 3. Now, before you do that, assuming you were given this, x over 2 plus 2 over x equals minus minus 1, what would you have done? What would you have done in this case?
Y.
Say that again.
Y equals 1.
We just draw the line of y equal to minus 1. Here we would have just drawn the line of y equal to minus 1, which would be like something like this. And it can't cut the graph, so we wouldn't do that. So this one is undefined. It has no solution because the graph doesn't touch it at all.
Okay.
What about if you're given this? X over 2 plus 2 over x equal to x plus 3. What will you do to solve this equation?
X to the other side.
Do you need to do that? Like I told you, you just look at what has replaced what.
Y equals x plus 3.
So you simply draw the line of y equal to x plus 3.
Yeah.
When you're drawing this, you know, I've told you how to do stuff like this. It's a straight line graph. How do you do this? You just need two values. Remember when I explained that to you? Let me even remind you. How do you draw this graph? Y equal to x plus 3. You just need two values,
Yeah.
x
so like
and y,
table.
and put in the tables. Which two values can you use? Any two values from this. But there's one value you don't even need. That one can't. Okay, it can. It really can. Can we? Okay.
1 and 4.
1 and 4.
1 and, yeah.
You just need to, for straight line graphs. For straight line graphs, you don't need all points. Just two values. So let's try 1 and 4. When x is 1, what will be the value of y? Yeah.
4.
For this particular line we are drawing, x will be y will be 4.
4.
Also, when x is which other one did you say I should use? Do you know you could actually have 3 and 0? The intercept is already given. What's the intercept?
3.
Sorry, this is the question I should be circling. The intercept is 3. What's the coordinate of the intercept?
3.
0, 3. 0, 3. But if you don't want to use that, you can pick up another value. Maybe we can pick up 2. When x is 2, any two values, I said, use any two values on x. Any two values along here. For instance, 1 and 2, or we can even use 1 and 3.
Okay.
Let's even use 1 and 3. Any two values along here, we do. Let's use 1 and 3. When x is 3, what is y? In this. When x is 3, what is y, please?
6.
6. So that's what we're going to plot in here, right? Sorry,
Yeah.
I just want us to practice it before. When x is 1, y is 4. Where is it? When x is 1, y is 4. We would have plotted. This is it now. When x is 1, y is 4. We would have plotted somewhere here, isn't it? Even though that's not what we're asked to do, but let's just practice it. We would have plotted here. That is for this. Because we are going to encounter this question very soon. When x is 1, y is 4, we plotted there. When x is 3, y is 6. When x is 3,
Yeah.
when x is 3, y is 6. So when x is 3, y is 6. 3, 4, 6. So we plot here too. So all we need to do is to join these 2 points, isn't it? We would have just joined these 2 points to get an answer. I've just joined these 2 points like this. Wherever it cuts the graph is the answer. This point where it cuts the graph.
Yeah.
You trace it down to the x value. What's this value? Approximately what? This place is approximately what?
Like 8.
0.8 thereabout. Okay, but let's go ahead and solve the one we're given. So let me just put this to here in case this is given. This is what we'll get. Okay, please go ahead and solve the ones we're given. We are given solve x over 2 plus 2 over x equals 3. And you said we draw the line of y equal to 3, isn't it?
Yeah.
And we've drawn that, this is it. So what are the answers? Because you're asked to solve it. What are the answers?
5.6 and 0.8.
Okay, you trace down. We trace down to here, where it cuts the graph. It cuts the graph here, and cuts the graph here. So we trace down, and trace down to this one too. So you're right. The answers are here and here. And I think here is 5.6. No, 0.8. Why this place is 5.6. Those would be the answers. 0.8 and 5.6. All right. I said this one would have given us. Let me just complete this one. When we plotted this graph, the yellow graph, it cut at this point. And if you trace this down, that's about 5.4, or almost 5.6 or 5.5 if you like. Around 5.5. This one would have given around x equal to 5.5. 0.5 I meant. 0.5 I meant. Or is it 0.6? Let's see. Yeah. 0.6. 0.6. Okay. Please, the last question for this one. Read it out.
By drawing a suitable time estimate of the gradient of the graph where x equals 1.
So by drawing a suitable tangent, work out an estimate of the gradient of the graph where x is equal to 1. Where x is equal to 1. Do you know what to do?
X equals to 1, so isn't that, it's like a straight line, but like here.
Can you use your laser and trace it? Let me see what you're talking about.
Wait. Like up there. It's a bit curved because I can't do a straight line, but
All right, you have an idea, but then we need to review what a tangent is. Look at this black graph I drew here. Can you see what I'm tracing? You may need to. That's a graph. The black line is a graph. Now, when we say tangent at a particular point, assuming this point is x equal to 2, the tangent should be drawn in such a way that it just touches the graph. Right?
Yeah.
In fact, if you have a circle, if I have a circle, a tangent is a line such that the angle exactly interesting, you know that. The angle between the radius of the circle to that line is always what? What's the angle between radius and tangent?
It's like half the diameter.
No, I mean the angle.
90 degrees.
90 degrees.
Yeah.
So the angle between radius and tangent is 90 degrees.
Okay.
Alright, so that's that. If you wanted to draw another tangent somewhere here, it would have been something like this. So that when you have the radius, it will form an angle of 90 degrees too. With the radius. So if they want if this is an arc and we want the tangent at this point, we just draw a line that touches it. And they said we should find the gradient. After we've drawn it, we just get the gradient of that line. Okay, we do the same thing here. It says at x equal to 1, it says draw a tangent. By drawing a suitable tangent, work out an estimate of the gradient of the graph where x is equal to 1. Where x is equal to 1. Where x is equal to 1. This is where x is equal to 1. Here.
Yeah.
This position. This is the position where x is equal to 1. This position.
Yeah.
So we're going to draw a tangent at this position. What color can I use now? Let me still use the green marker and draw a tangent at that position. Something like this. Did you see that?
Yeah.
That's a tangent. And they say we should find what?
The gradient.
How do you find the gradient of the line you just drew? Remember, the tangent will be at x equal to 1, this point.
Yeah.
So find the gradient of this line we just drew.
Yeah, okay, so if you drew like
What's gradient? You know, gradient is m.
yeah.
You want
rise over run.
rise over run. Let's just do rise over run instead of drawing triangles. There's no need for triangles. Just do rise over run. No, you don't need that. Can you undo?
Okay.
The rise is clear, the run is clear, so we don't need that. But you could draw that triangle if you wanted. This is already the rise. From 0 to 4 is rise. From 0 to 3 is run. From 0 to 4 is rise. By the way, gradient is equals rise over run. Oh, sorry, just a moment. Let me write the formula. Rise over run. You just need to be careful how the sign you allocate to the gradient. The rise is the vertical height. Rise. Run is the horizontal height. Run. But there's a way I want you to do it so that you I can actually teach you this. Are you ready for this?
Yeah.
Let me teach it in two ways. You said the rise is 4 over 3 because you've not indicated the correct sign. That's why I want to sound this alarm. 4 over 3. Yes, 4 over 3 is rise 4.
It's 1.3.
Or 1.3 recurring.
Yeah.
But that's not the answer. What's the sign? What sign should it have? You know, it is sloping downwards.
Yeah, minus.
So it should have a minus.
Yeah.
So it should actually be minus 1.33. Minus 1.33 recurring. You know, that's that for that. I want us to try this. Let me see what I can give you. Okay. Go to page 8 of 20. Okay, this should be 11.5. Are you ready? So, the question says complete the values, the table of values of y equal to 2 over x squared minus 1 over x minus 3x. And I said when you are plotting this, you should be careful. For instance, for minus 0.5, that's the one I was checking now. Look at the one for minus 0.5. When x is equal to minus 0.5, are you seeing that? You know, you are putting minus 0.5 into these places. So that minus 0.5 should be put in a bracket before you square it. That's all I need you to take note of. The minus 0.5 should be put in a bracket before you square it. Then wherever you have x, replace it with minus 0.5. Wherever you have x, replace it with minus 0.5. You know, after that, when you press equal to it will give you 11.5. So I know 7 wasn't given. We completed it to find 7. This 4.5 was also not given. We completed to find it. So here, these were the things we found: 7 for here and 4.5 here. I've verified this one is correct. I know the other ones will also be correct. So after you've done that, you plotted it. This is what we plotted. Are you listening?
Yeah, I'm listening.
Okay. We plotted this. So, what did the question say we should do? Let me see if I can repeat this to get the details again. Let me see what the question requires us to do. We're going to review it again. So, these are the questions.
Okay.
Read it.
Use your graph to solve these equations. 2 over x squared minus 1x gives, minus 3x gives 0.
Let me say that again. Use your graph to solve this equation. 2 over x squared minus 1 over x minus 3x equals 0. So what do we do?
Um,
Remember what you plotted.
Yeah.
Just make sure what you plotted is exactly that. Is what you plotted exactly what is written here?
Yeah.
Because it must be exactly that first before you do all that you are trying to do. It's exactly that. So, what do you do?
So. Yeah. So does that not mean like y equals 0?
Exactly. That's like y equals 0. Let me erase this so that we do that again. Y equals 0. The reason is everything we have here is the same thing as what we have here, or what we have here. Everything we have here is the same thing as what we have here. So the y is replaced by 0. So it's draw the line of y equals to 0, isn't it?
Yeah.
So let's draw it. Because y is now replaced by 0. The y here is 0. Because all of these are still the same. It must be the same for you to conclude that. So let's draw the line of y equal to 0. Can you draw the line of y equal to 0 on this graph?
Yeah.
Okay, go ahead. Draw the line of y equal to 0 on this graph. Good. That's the line of y equal to 0. So where it cuts the graph will be the answer. Where did it cut the graph? It should be here.
Yeah.
What's the value?
0. I mean, sorry.
Yeah, you're right. I think it's 0.8.
Yeah.
About 0.8. So the answer will be 0.8. All right. Next question.
Yeah. So
Let's go. We're making progress.
Yeah. 2x minus 1x minus 3x minus 7.5 is 0. So, do we put it in the table?
There's nothing to put in the table. You can't be asked to start plotting another table. First of all, you need to check if what you have here is the same thing as what you have here. If it is
not the same.
It's not the same. So is there nothing you can do for it to become the same?
Oh yeah, like move that.
Move exactly. If we move this to the other side, it becomes that. Alright, so if you move that, it becomes x 2 over x minus, good, 2 over x minus 1 over x minus 3x equals 7.5, good. So let me just write it properly so that when you are reading it, you will see what you wrote. Two over x squared minus 1 over x minus 3x will be equal to, when this minus 7.5 is moved to the other side, it becomes 7.5. Okay. So draw the line. Can you draw that?
Yeah.
We draw the line y equal to 7.5. Because this has been replaced by 7.5. Since the whole of here is the same now as the whole of here. So draw the line of y equal to 7.5. Go ahead. Yeah. Are you sure that's where 7.5 will be? No.
No, wait, hold on. No.
If this is 5 and this is 10, 7.5 should be midway between 5 and 10 now, isn't it?
Yeah.
Or even if you're in doubt, you can see that this is 5, 6, 7. Okay. Alright, that's because there are two spaces. So this is 5, this place will be 6, this place will be 7, this will be 7.5. 7.5. 7.5 is exactly midway. Yeah. No, you need to make the line longer. It has to cut the entire graphs. Everywhere in the graph. Except if you cannot cut. Once you can cut, good. So let's look at the positions you cut the graph. You cut the graph here, you cut the graph here, and here. So what are their values? Once it has cut the graph, you don't need to keep making it longer. So you trace it down to get the value. So what are their values? Let's go.
0.5. Oh, accidentally just left the ground.
Here is these positions now. Here, here, and here.
Yeah, no, I'm not on the Jamboard, just I accidentally left. Hold on.
Oh, okay.
Yeah, so 0.5.
Okay, here is 0.5.
Minus 0.7.
Okay, this is 0.5. This one is minus 0.7. This one should be what?
Minus
2 thereabout. Or 2 point, yeah, minus 2.3. So we have minus 2.3, minus 0.7, and 0.5. So those three answers. Yeah. 0.5 minus 0.7 minus 2.3. Okay. Look at this question now.
Yeah.
Read it out.
By drawing a suitable straight line on the graph, solve the equation.
Let me stop circling it so that you see. Solve the equation. So what do you do?
So y equals 10 minus 3x.
Okay, so we're going to draw the graph of y equal to 10 minus 3x.
Yeah, which
And we've already found the table of values. You need any 2 points, right?
yeah.
Y equal to 10 minus 3x. We found the table of values for 1. When x is 1, y is 7, because 10 minus 3 will be 7. When x is 2, y will be 4, because 10 minus 6, when x is 2, it will be 10 minus 6 will be 4. So we plot 1 against 7, 2 against 4. Can we do that? 1 and 7, 2 and 4. Let's plot 1 and 7, 2 and 4.
Okay,
1 and 7 should be somewhere here. Let me plot with a green marker. 1 and 7 should be somewhere here. Right? Then 2 and 4 should be somewhere here. We've plotted the 2 points. So what do? We join them, isn't it?
Yeah.
That's that. By the way, this line is the line of y equal to 10 minus 3x is this line. So how do we solve the equation now? Where it cuts the graph, isn't it?
Yeah, where it cuts.
At this point and at this point. And at this point we trace down, almost like the other one. This one we trace down to here. This is about minus 0.4, here is about minus 0.4, and here is about minus 0. This is about 0.5. So it's about minus 0.4 and 0.5. Where you trace down this position and this position. Okay?
Okay.
Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to two main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +2 34808 509 5144 to learn more and get started today.